new Shiny converter for untargeted data can use many different formats as input. However, most of them look very similar. For example, MZ-Mine and L-Maven have more or less the same kind of input format. And also, Binner uses a very similar kind of input-output format. So what have we here? We have an MZ-Mine output. And what we see here is that here's a column for MZ, here's a column for retention time, then there's some stuff that the program puts out, which may or may be interesting to us. But then, at some point here, we find the first sample column. So here are the intensities for this sample. And then it carries on with lots and lots of sample columns. And then we have here, in fact, the last sample column. So the information the parser needs is the first sample column, the last sample column, the MZ column, the retention time column, and a peak width column if there is one. Here there isn't. Now let's have a look how that looks in the Shiny. So, start it again. Here we go. So we have this familiar interface for loading files. So here we use L-Maven format. QI is different. So QI, the QI format will be passed either the raw or the normalized intensities, but I'm now focusing on the other types. Okay, I use old school because that's I've got it on my desktop somewhere. So I select a file. It's a CSV. I think I have it somewhere. It doesn't really matter. Okay, I've been working with this file mostly, and here it goes. And then what you need to do down here is you have to select the MZ file, the column, which in this case is very easy because it's called MZ. No, you've got to select the first data column here. That's this one here. And then this one automatically jumps to the last column, which happens to be also the correct one. And then we have to locate the MZ column, which is okay. So this wasn't quite correct here. So here we are. So now we don't have all that much left to choose from. And finally, if we have a peak width column, we could select it, but then there's none. Okay, so this is the first sample. This is the last sample. This is the MZ column and the R2 column as it appears in the CSV file. And then you've got to press pass. And then this was an output from Binner, for example. Slightly needed to be pre-processed a little bit to fit in here. And okay, then once I get this message successfully passed, I can move on to the next tab. Here we are in samples, so it shows me what kind of samples I've got. Then what one should do is one should tell the program which samples are the non-biological ones, because there's no way that the algorithm can tell this by itself. So first we select all of them here. So there's only pools in here. And then this is sort of a novelty. Then from these pools, if there was a blank in here, from all of these non-biological samples, we could also select blanks, because blanks are really quite different to pools. Okay, so we don't have any blanks here. And then it's also a novelty. We can now also upload your experimental design. The experimental design is on my desktop. It's this one here. And what it's done, it's now got all kinds of columns: biosample ID, name, section, age, order. These are the columns that were in the file. So let's go to Excel and have a look at this file. What does it look like? So it needs to have an MS sample ID column that matches exactly some of the names, or all of the names in the output format from the untargeted peaks from the peak table. So this needs to match exactly to the peak table. Then it should have a biosample ID. This is at this stage not so important, but later on it will become important. So this one is a mandatory column. You've got to have biosample ID. And then there's all the other stuff that somehow describes the experiment. And this is like it was in Super Shiny before. Only that here now the difference is you don't put it in later. You can you prepare this file and then you load it while running the converter. And all of these columns will now be over here. So name, section, age, order, they're here. And yeah. So in addition, we have this information here that comes from what we've just done ourselves. So these are pools. Other than the tick and the mic is the median. They're calculated automatically and they're already here for later use in normalization. Yes, and so now we've done everything that we could do at this stage to the samples, and we move on to compounds. So here would be good if we had some internal standards here. This, as far as I know, there are none here. I'll just pick some at random because that will later on be useful. Okay, so oops, I've pressed this by mistake. So I select some more of these. Yeah. So up here now it says internal standard yes for these two features here. And here's some stuff that so this is something that is calculated, the median intensity of this feature. Useful. Oops. This here comes from the original file. This is a column that was already in the original file. And then here we've got something that's called bad val. This is how many values are in there that could cause problems. These are missing values or zero values or negative values. So they're already shown here that this here may have some problems. Okay, so if you don't like some of the columns that came from the export of the previous program, you can remove them. For example, if you don't like to have feature here as a that's more or less the same, isn't it, as compound ID. Then you just remove it and it's gone. And there could be quite a lot of sort of rubbishy columns that you might want to get rid of this way. And this concludes sort of the first part of this, what you can do with this program. So you load the peak table, and then you can load some experimental design, and you select your standards and your internal standards and your blanks and pools, and then move on to the next step, which is normalization, which will be treated in the next video.